Hey everyone, so we are going to start from the day 3, the questions from Maths Easy Part C, and talking about day 2. So the recordings haven't been uploaded as of now, so because of some errors and technical issues. And just in case if you want to know about the solution of this question, you can always message me and let you know. So without further ado, let's move on to the questions for today. We have 30 questions. We also tried to solve some questions, easy questions related to bit manipulation. So, in order to make this a rounding number of 30 questions. Apart from that, I would say that the recording of the sessions would be uh, broken down into 30 minutes as it will be better in case you try to upload them using that. So, yeah, that's just it. Uh, we move on to the next question, that is day of the year. So we are given a string date representing the Gregorian calendar formatted as YYYY, MM, and DD. We are asked to return the day number for the year. So what we think of is we are given a string, and for that particular string, we need to just change that and make it into return the day number for the year. So we need to handle the leap years. What we can think of, we need to handle the leap years, and apart from that, I think it would be just fine if we just uh, okay. So we need to extract the day also. We need to extract that particular day which is present. So what can we do is we can just extract all this data. Now since this is the string, we can just simply extract this data into int year equals date. So using the Sqrt function, we can easily do this, and the number of characters is 4, and because we will be passing this to a function, and same goes for month. For month, pass the same. We copy this and we try to change only the parameters which are passed in the Sqrt function. That is, we are starting from the index 0, 1, 2, 3, 4, 5, and we are taking two characters after that, so that would be 2. Same goes for day 1. We do the same thing for this. Try to paste the earlier implementation, and as you can see, this index will be, if this is 0, 1, 2, 3, 4, 5, 6, 7, 8, the index will be 8, and the number of characters will be 2. Once we get entire information, we could simply say that, okay, so what can we do is we can simply make a vector consist of days of months. So we can just make days of month vector, and for 0 base, I'm taking 1 base indexing, so I'm applying 31 over here. Then as you can see, there's 28. Generally it is 28, we are assuming it's a non-leap year. Then we go 30 for 1 for June, we again go 30 for July, for August, for September, for October, for November, and ultimately December. We have uploaded this. We have passed as a vector. Now simply we could say that if here modulo 4 is equal to 0, so the condition of leap year is that it should be divisible by 4 and 400, but not 400. It should be divisible by 4 by uh, excuse me. So the condition of leap years is that there are two conditions basically. So if it is directly divisible by 400, we could just simply add 1 to a particular day. There should be a particular answer which stores the number of days, right? So the answer is equal to 0 for now, and we are checking the conditions. If either this happens, or if we would simply say that here modulo 4 equals to 0, and uh, here modulo 100 should not be equal to 0. If it is equal to 0, then simply mean that so the condition of leap year is such that it should be either divisible by 400 or it should be divisible by 4, but it should not be divisible by 100. Like if here modulo 100 is not equal to 0, then we could simply say that yeah, this could and consider a leap year, because 1900 is not a leap year as it is divisible by 100, but it is not divisible by 400, and that makes it a non-leap year. So if we try to do this, that particular years we already increment the answer, or we could just simply say instead of incrementing our answer, we can change the value of February as 29. Value of February as 29. The functionality of year is clear to us. In order to use the month, we can just simply apply a for loop for int I is equals to 0, I less than month, um, month minus 1. Okay, so we just that particular month, we could just answer from date of month I, and here we are able to calculate all the days which are present behind the months, and the thing which is left is counting the number of days. So you can just simply this this. Okay, so I go this. Let me see if it is using. Yes, it's fine. It's working. So without further ado, let's move to the next question. Climbing a staircase, it takes n steps to reach the top. Each time you can either climb one or two stairs. In how many distinct ways can you climb to the top? So we are given n staircase. Okay, we are given an n staircase that is like this, and we could either take one step or two steps. So we can either move here, or we can move to here and then here and then here. So uh, this is a standard dynamic programming question, which is this basic dynamic programming question. So if you don't know about the question, I would suggest you watch some videos regarding recursion. And this is a recursive problem. Like suppose what can I do is I can consider taking one step and try to do either I could just take one step and call the problem for the remaining particular subproblem for n minus 1 staircases, or what can I do is I can call it for n minus 2. I could call the same problem. I could, and we need to solve, we need to basically, what we need to do is we just need to count that number of test cases. We need to add all these cases which are happening. So uh, the number of ways to reach that particular end staircase would be num in number of times that we need to calculate for fn minus 1 and for fn minus 2. So if you can just see, it's a Fibonacci series problem. Like you can just call it like in this way. For example, for n is equal to 1, there is only one way, right, to climb staircase. For n is equal to 2, we could do it in this way, or we could just simply do it in this way, right? It has two cases. This n is equal to 2, it has two cases, right? For n is equal to 3, that means like this. To here, here we can move to here. Or what we can do is we can move to here, we can move to here, we can move to here. This is one case, right? And this is one. Apart from that, what we can do is we can take this particular case. So this is one case. Update it to, apart from that, what we can do is we can move from here. This is also considered a case 3, and I think we are all out of solution. We are all out of problems. So the number of cases that could occur is basically 3. So how did we come to this fact that it is 3? So if we try to say that what is generally happening is that we could just talk about this. We need to calculate the number of ways which are possible. So if we are basically over the n minus 1 stair or n minus 2 stair, the only possible solution is that we could either jump one staircase or we could jump two staircases. In the case of n minus 2, we could jump two and make it n, or we are in the n minus 1 staircase, we can jump to 1 and we can make it the nth particular combination. So we only have one choice which is left remaining. So that means the number of ways to either reach this particular n staircase would be the number of cases that we have for n minus 2 summed up with the number of cases that we have for n minus 1. So we could just say that if n is less than equal to, I'll try to have a recursive solution. If n is so we'll be returning 0 that. If n equal to 1 or n equal to 2, I'll just say return simply n, and then I'll try to call this recursive function that is climb stairs. You could just optimize it to O1, but that will be discussed later on when we are going to solve some questions based on dynamic programming. So this is, try to submit it. I think it should work. Okay. Name is wrong. For this particular case, it is time limit exceeded. Okay. Yeah, because of course there's a recursion. So if you are using recursion, then it would lead to for each particular test case, like for example for 33, if you could just say for 33, it would divide into 31 and 32, and let's just try to make a recursive tree out of this. 3 is there, 31, 32, this will call their own function. So as you can see that if you just are able to see that it's going to be a huge tree, and the tree is going to be somewhere around the exponential order. Hence, time limit is getting exceeded. In order to avoid that, let's do one simple thing. Let's try to do it. Let's try to memorize it. So what we can do is we can just declare um, instead of memoizing, I could just move the optimal O1 solution, which is that instead of keeping track of all those states, you could just simply keep a track of the recurring states which are actually happening. So let's just say that we have for n is equal to 1, for n is equal to 1, we have a particular option. So for int f1 equals 1, int f2 equals 2, int f, then for int I equals 2. I is equal to 3, I less than equal to n, I plus plus, if n equal to 0 or n equal to 1 or n equal to 2, simply return n. F is equal to f1 plus f2. Time to change f2, f2 will be equal to f, but since we also need value of f2, original value of f2, change it to f2. F2 will be modified to f, and then we'll be returning f. Basic O1 solution, O1 space optimized solution. For 2, it's working fine. Let's try to do it for the, yeah, it's working fine. So crux was that in order to make a recursive solution to an optimized solution, we could first memoize it. I have avoided the memoized solution for now. I've just deleted implementing the optimized solution which is possible. The memoization part will be discussed later on when we try to solve questions related to DB. So let's move on to the next question, which is given to binary strings A and B. We are required to return this sum as a binary string. Okay, so we have a string as A is equal to 11, B is equal to 1. We need to add some strings. So what we can simply do is we could just declare string result. Simply declare a variable which is present. This is the question that we uh, have seen a similar question on day 2, where we were asked to add the strings. The strings were in decimal format. Here we are given these binary strings. The only thing that will be changed will be instead of modulo 10, it will be modulo 2, and everything would be remaining as it is. So what we'll do is we'll try to have two indexes. One is a dot size minus 1, and int I2 will be a dot size minus 1. And then what we'll try to do is while we also need to have carry. So int carry is equal to 0, while I1 is greater than equal to 0, or I2 is greater than equal to 0, or simply say that carry is greater than 0. We are required to do something, and we will be returning the resultant strings. That will be the resultant strings we're talking about. And as you can see that since we are going from backwards, why we are going from backwards? Because normally when we try to do some based option, for example, this is a decimal format, 45 plus 27. So we always start from here, and then after that add this, then we update it over here. We apply this carry, then 1 4 2 7. So this is how we move from the rightmost digit which is present to the leftmost digit, and the same thing we are doing here also. If we try to do, if the value of I1 is greater than equal to 0, then we could just simply say that okay, so we need to do carry, we are modifying carry. So carry plus equal to a of I1 minus that particular integer, because it's a character, and in order to get integer we are subtracting this value, of course, and for that we need to just do I1 minus minus. Simply that's if the same thing we're going to do for I2 as well. Carry plus equals to p of I2 minus, and then I2 minus minus. If I1 is greater than equal to 0, if I2 is greater than equal to 0, everything is okay. What we can do is we can just res plus equal to carry. We need to get that standard particular digit. So instead of 10, it would be 2, and then carry would be 2 divided by equal to 2, and that's just it. So able to get that particular integer is plus that 0, and then carry gets added, and that's just it. So I think this will work. Let's see. Conditions are okay for now. Okay, yeah. So since we added it in this way, like appending this result as 27, this will be appended as 27. So in order to get 72, we'll have to reverse this entire particular string. So yeah, this was an important point that I had missed. In order to reverse, we need to begin, and then that's it. So yeah, this particular subtail. test case. Let's see if it works for all the test cases. Yeah, it's working. So yeah, here you can see that we try to add all the binary series which are present. So next up, we have some questions. We have solved day of the year. We have solved climbing stairs. We have solved add binary. We have also tried to solve. The next question that we'll be solving is base 7, maximum product, and confusing number.